which is going to be a new type of graph that we're going to talk about. An absolute value function. Okay, what does it look like on a graph? What are its properties? Like I said, grade 10 last year, we did linear functions or lines. And we talked about domain and range and slope and x-intercept and y-intercept and different properties. Earlier this year, we talked about quadratic functions or parabolas. And again, we talked about domain and range and x-intercept and y-intercept, but then we also included things like vertex and axis of symmetry, maximum and minimum, things like that. So now we're going to talk about absolute value function, which is a function that involves the absolute value of a variable. And the most basic one, okay? Just like the most basic linear function is y equals x. Nothing in front of the x, nothing after the x. The most basic quadratic function is y equals x squared. Nothing in front of the x, nothing after the x squared, sorry, the x squared. The most basic, like I said, absolute value function is this one here. So what does it look like? So what we're going to do is we're going to graph this first. So this is going back to grade 10. And we're going to do a table of values, which is usually a good way to start learning what these graphs look like. And we'll just do -3, -2, -1, 0, 1, 2, 3. So for the graph, y equals x. If x is -3, what's y? -3, it's the same thing. Y equals x. And that applies to all the points. Like so. So if we plot all these points, it's going to look like this. And then I just draw a line through. So that's the graph y equals x. But what does y equal absolute value x look like? Well, let's take these x's and find their absolute values. So if x is -3, what's y going to be in this function? 3. Anything that's negative changes to positive. Anything that's positive stays exactly as it was. So what does the absolute value function look like? Well, -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. And it looks like that, a V shape. Okay. And just a question for you. What's the difference between y equals x, and y equals the absolute value of x. What's the difference between those two? Can anybody explain it? What did we do to the purple one that made it the blue one? No? Where did all these points go on the absolute value? Where did they go? They went up here, right? So anything that was below the x-axis flipped above. Anything that was above the x-axis stayed exactly where it was. Okay? So these flipped above. And that applies to every single point. So all negative x values in the original one became positive in y equals absolute value of x. And all positive x values in y equals x, the original one, stayed the same. In the absolute value function. So that tells us how to graph absolute value functions. Graph it without the absolute value. And then when you put in the absolute value, anything on the graph that's below the x or below the x-axis flips above. So let's look at an example. I should have put that, I gotta change this lesson. This should actually be down here. We're gonna sketch the graph first. Okay. So what we're gonna do is we're gonna sketch it. Oops. Without the absolute value. Do you remember how to sketch a line from grade 10? That formula that we used. Yes, you can use a table of values. There was another way. There was a certain formula that we used. Y equals mx plus b, where m represented b, slope, and b represented b, nothing? You got nothing for me on a Monday morning? Y-intercept. So this is the slope. This is the y-intercept. So how we graph these is we plot the slope first, okay? Or sorry, plot the y-intercept first. 2, 4, 6. That's 1 point on the line. And then we use the slope to find the second point on the line. So remember, slope is rise over run. So from the y-intercept, using this slope, I rise 3 or up 3 and run 1 or to the right 1. So it looks like that. Now you want to draw an accurate line here, okay? Notice From here to here, it's down 3 across 1, down 3 across 1, down 3 across 1, down 3 across 1. So I've got points, I should have even gone maybe a little further. Okay. Now, put in the absolute value. What do I do with all these points down here when I take their absolute value? Where do I take all these points? Up here, right? So this doesn't flip anywhere. This flips up here. This flips up here. And that's part of the absolute value graph. Because remember, the other half of the absolute value graph is this section here. You have to make that clear when you graph it. Sometimes students will just using a pencil go like this. I'm not giving full marks for that because you haven't made it clear to me what part is the absolute value. So I don't know, use a different pen color, use a highlighter, something to make it clear. Okay, because this is not complete. Just remember that. Okay, now we can answer some questions. And ideally, if we can answer the questions from the graph, that's easier than having to do algebra. Remember, X and Y intercept, you can read it from the graph or do algebra if it's hard to read from the graph. X-intercepts looks pretty easy to read from the graph. What is the X-intercept? Here I am. Right? Where does it cross the X-axis? -2. What's the Y-intercept? Read it off the graph. Where does it hit the Y-axis? 6. Yeah, the X coordinate is 0. But we want the Y. And domain and range. You could write this in either interval notation, which most of you usually do, or you can write it in set notation. What's the domain? Look at the blue one. Really? Negative infinity to plus. The range. Lowest to highest. The blue one. Zero to infinity. With what kind of symbol around the 0? Just being included. Okay. Most of the absolute value functions we're going to look at, and even next year, are V-shaped, but they don't have to be. It depends what's inside. This one, and again, we'll do the sketch first, okay? We've got a quadratic function inside. Which is going to involve a curve. So just like we did with the other one, I want to sketch it without the absolute value bars first. So it's going to be negative x squared plus 2x plus 8. How do we graph this? What do we need to find? The what? X vertex and then Y vertex. How do I find the X vertex? Sorry? No, that's the intercept. Negative b over 2a. Which is going to be negative 2 over 2 times negative 1. Which gives me 1. Then I have to find the Y vertex by plugging the X vertex into the function and solving for Y. Be careful here, this is not negative 1 squared. This is 1 squared, then a negative. So this is negative 1, plus 2 is positive 1, plus 8 is positive 9. So our vertex is 1, 9. Up or down? Down. And it's regular, there's no stretch. So regular opens down. So we got to plot 1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up here. We're going down and it's regular, so 1, 1. Back to the vertex, then 2 across. How many down? 4. And actually with this one, we want to see where it hits the x-axis. So we're going to do another one. 3 across, how many down? 3 squared, right? So 9. So it's going to look like this. Remember, we're not finished yet. That's just the non-absolute value part. Now we've got to put in the absolute value. And how do you do that? Anything that's below, flip it above. Anything that's above, just copy it again. So these flip up here. This all is above. So it looks like that, kind of a weird looking shape. That's what the absolute value one looks like. And again, we can state properties. What's the y-intercept? Where does this thing hit the y-axis? What value for y? 8. Notice you are asked for the x-intercepts. Why? Because there's 2 of them. And where are they?
-2 and +4.
-2 and +4. And what's the domain of this function?
Negative
Infinity to positive infinity. And the range? Range would be lowest to highest.
infinity to 8.
Sorry?
Negative infinity to 8.
Negative infinity to 8. That's for the original. That's not for the absolute value one. Look at the blue one. What's the lowest y value? Or sorry, x value? Y value? 0, right? What's the highest? Goes up forever. So it's actually going to be, once again, 0 to infinity. Any kind of absolute value function like this that we graph, the domain will always be everything. The range will always start at 0 and go up to infinity. Okay? That would only change if there's stuff outside the absolute value. So you can see that we've started, and this is good. This is kind of a preview of grade 12. Okay? Like in grade 10, we graph this and then numbers around it. This year, we graph this, and now we graph this. Later this year, we're going to graph this. Next year, we're going to graph this. Then this. And then cosine, and then tan. And then this. And then this. Oh my God. That's crazy. But the nice thing is that when we start throwing numbers in, depending on where the numbers are, it does the same kind of thing to it. So if we just learn those kind of things that does, which we actually did earlier this year, you'll find actually these aren't too bad. Okay? Sorry, I didn't mean to scare anybody.